Hi, this is Bill for Sparky Channel, and today I'm going to bring you the ideal national championships for apprentice electricians from the Tampa Convention Center in Tampa, Florida. 10 very skilled apprentice electricians have won qualifying rounds to be able to be here. The winner will win $40,000, second place $20,000, and third place will win $10,000. There are 2 rounds to this championship, so the first contest is actually the semifinals, and the contest will be service installation. The 10 contestants are to install a 3-phase meter which accepts underground service entrance cables, a wireway, which we call a trough, and a conduit raceway. The challenge will start with a Siemens 200 amp panel and a Siemens 200 amp safety disconnect switch pre-installed, and they are connected with a 2-inch by 12-inch rigid nipple. The contestants must meet the requirements of the National Electrical Code. All measurements must be within plus or minus 1/8 of an inch, and conduit must be cut square and deburred. No additional conduit will be provided. I'll explain more later. Let's get started.
And here we go, electricians, begin!
Let's meet the contestants. This is Dino Gualandri from LaSalle, Illinois. Luis Sanchez from Chicago, Illinois. Devin Silfer from Greenup, Kentucky. Jake Tribby from Waverly, Ohio. Donald Reed from Brandon, Mississippi. Hugo Ponce from Houston, Texas. Herman Vasquez from West Palm Beach, Florida. Emma Becker from Denver, North Carolina. Agapito Arvizu from West Palm Beach, Florida. And Jose Renteria from Elk River, Minnesota. There are 5 pros available for these apprentices to ask questions of. The pros are not allowed to do any work, but they are allowed to answer questions. There is 1 pro for every 2 apprentices. Here is an example.
You've got to drill a hole. So they're changing that on the fly. This is way out here. They want you to drill a hole back. Otherwise you're on your right move over here. So you got that little nub to worry about.
Let's watch Luis Sanchez in action. Luis won 3rd place and $10,000 last year in this competition. Luis already has the 12-inch by 2-inch rigid nipple installed into the safety disconnect switch. Now Luis will install the 200 amp meter socket, and he will prepare it for the installation of the 2-inch rigid PVC conduit for the underground service entrance cables. One important part of this installation is that everything needs to be level and plumb. Notice the magnetic level on the side of the meter socket. Now that his meter socket and rigid nipple are level and plumb and secured well, he will work on making a 2-inch knockout for his 2-inch rigid PVC conduit. Now he'll use the appropriate adapter lock nut and bushing in the 2-inch hole, and he'll tighten it up. At this point, Luis has installed the 12-inch by 2-inch nipple and he has the lock nut and plastic 2-inch bushing on one end. Note that both knockouts have concentric rings. All competitors have been given a 2-inch grounding bushing, which should be used on at least one of these connections. Here's an example from another competitor who correctly placed his grounding bushing. I'll be making a separate video on grounding bushings, complete with 2023 NEC code review on the subject. Be looking for that video if you would like more information about grounding bushings. One thing I noticed about the plastic bushings is that multiple contestants broke them when they screwed them on the threads. You see the crack right here, and I noticed that multiple times. So those plastic bushings aren't meant to keep anything in place. They're meant to have a low friction surface for your cables to pass through. Notice he's using his lineman's pliers as a hammer. Those are ideal lineman's pliers, and they're actually designed to be used as a hammer. Luis is now installing his grounding bushing in the area where there are concentric rings, and it's on the panel of first disconnect, which is the safety switch. So we have the grounding bushing, which has a nylon insert to reduce friction, and then we have the plastic bushings on each end of the 12-inch nipple. Now he's going to create a PVC conduit for his grounding electrode conductor. The grounding electrode conductor, or GEC, will be connected to his grounding electrodes, which are also called ground rods. He has drilled a hole for his 1/2-inch PVC fittings. Also, he has chosen the correct box to run the GEC to. That's a flex bandsaw there that he just grabbed to cut his PVC. Now he'll glue his PVC to his PVC fitting. Then he'll check for level and fasten the conduit to the wall. Now Luis will grab his 2-inch Ideal TKO drill bit. These bits are designed to drill through metal such as you find in electrical boxes. I have a video about these bits that I will put a link to in the video description. Now Luis has unboxed a wireway, or as we call it, a trough. Here Luis is asking the pro, Anthony Kowalczyk, a question. The two 6-inch nipples are going to run from the top of the load center to the trough. Now he is measuring up to put holes in the top of the panel, and then he's going to put corresponding holes into the trough, and they have to line up exactly. He is to use Myers hubs at the panel, and he is to use lock nuts and bushings at the trough. He's drilling the 2-inch holes now, and he's using the Ideal Deadeye magnetic chip collector. He's measuring again because the holes in the top of the panel and the holes in the bottom of the trough have to line up perfectly. Most pros would simply put the trough on top of the panel, and once the holes were drilled in the panel, and then just trace with a Sharpie onto the trough. But he's using the measuring method, which can work out fine as well. He has his marks, and now it's time to drill. He'll install the two 6-inch nipples into the top of the panel. Now let's see if the nipples line up with the holes that were drilled in the trough.
Left. 1 hour, 15 minutes.
Okay, here's the situation. The holes that he just drilled in the trough do not match up with the nipples that come from the panel. So what should be done right here is he should stop and ask the pro that he was furnished what to do. You know, what should I do? Say, I've made a mistake, I mismeasured, and what can I do? You know, and maybe perhaps they have another trough they could give him. Perhaps there's a sheet metal fix. You know, perhaps they'll, I don't know what I would do as a electrical contractor is I'd probably go buy another one. But for now, Luis has put aside the trough with the mismeasured holes, and he's going to work on the service entrance conduit, which will be made up from 2-inch rigid PVC. Also, it is to have an expansion coupling. This is the expansion coupling. It can expand and contract during really cold weather. Now back to the problem trough. You may have heard me say, "Oh no," in the background. This is very, very dangerous. Safety is the #1 issue that is judged by the judges as they come around to check people's work. And if you do something unsafe, you pretty well have lost. That's how serious it is. in these ideal contests. He's trying to expand the hole, but that's not really going to work because the load center, the safety switch, and the meter socket are all rated NEMA 3R, and that's for outdoor applications. That's to protect these boxes from rain and sleet and ice and things like that. And if you expand the hole, you leave a big hole, you know. It's not NEMA 3R anymore like the rest of the boxes. So that's really not going to work. I think the best thing to do is to just, you know, admit, hey, I made a mistake. I mismeasured. What can we do? I'm willing to have some points taken away, you know, because I mismeasured. But what can I do? You know, that kind of approach is probably better. Luis will now measure up to drill a hole to accept his 1-inch EMT. Now he'll drill a hole for his 1-inch EMT fitting. Now he'll use his ideal reaming tool to make the end of the conduit nice and smooth. With the fitting installed on the end of the EMT, he will tighten up the fitting's lock nut. And now to get the conduit nice and level, and put a couple straps on it. Now Luis will run his green number 4 ground wire, which we call the grounding electrode conductor, or GEC for short. He'll run it up the PVC conduit and into the safety switch. Then he'll run it over to one of the grounding electrodes. You can also call them ground rods. The GEC must stay continuous throughout this entire run. So you can see he's stripping off a piece of the insulation of the GEC. Now he's tightening on what we call an acorn clamp, and it will look like this. Notice he has kept the GEC continuous in this way. The second grounding electrode connection looks like this. He'll connect the GEC to the ground bar right here, and then it goes down to his PVC conduit. Now Luis is going to run his ground wire from the load center to the safety switch. However, this time the ground wire is called an equipment grounding conductor, or EGC. If you would like to know more about GECs and EGCs, I'll put a link in my video description for my video entitled, "What's the difference between an EGC and a GEC?" Luis will run his EGC to the ground bar in the load center. Luis is running his EGC through his grounding bushing. You can see that the 2-inch hole in the safety switch has concentric knockouts. Therefore, it needs a grounding bushing right here. So you can see the EGC comes into the safety switch, goes into the grounding bushing, and then he's going to hook it up to the ground bar. Here you can see that the EGC is hooked up to the ground bar. Now he's going to grab the 3/0 electrical cables. This cable is made by Wire. Luis ran 2 cables at once from the safety switch to the load center. He's going to mark one with black electrical tape and the other with red electrical tape. Let me explain what he's doing here. The black cable on your left receives the black cable. The middle lug receives the red cable, and the lug on your right will receive the blue cable a little later. Then you see the neutral goes to the neutral bar, and the EGC goes to the ground bar. And notice there is a 200 amp main breaker in this panel. Now Luis is going to run 2 more cables from the safety switch to the load center. These cables are going to be for his blue hot cable and for his white neutral cable. Here Luis will land his blue hot cable. Notice that he marks his cables on both ends so that he doesn't get them mixed up. He'll land the neutral cable on the neutral bar. Now Luis will torque down the various terminals. The torquing specifications can be found on the inside of the load center. Here are the torquing specifications. I'm going to stop the video right here because Luis is about to commit a major blunder. Where he has a screwdriver is the bonding screw that's in the load center. This screw will connect the neutral to the ground. This screw will connect the neutral to the EGC at the ground, and it should not be connected in this panel at all. This screw should not be screwed in. The best thing to do is take it completely out. There he goes. It's screwed in. Okay, let me show you photographs from other competitors. Here's a photograph from another competitor later on in the competition, and you see the green bonding screw is left loose. That's the way it comes, and you can let it loose like that. That works. That does not bond the neutral and the ground, so he's okay. Here's another photograph from another competitor later in the competition, and he completely removed the bonding screw, which is even better because that will prevent a do-it-yourselfer or someone coming around later on and say, oh, this isn't tightened up, and tighten it up, because that would then bond the ground and the neutral in a panel where it is not to be bonded. The bonding screw that does need to be tightened down is found in this case in the safety switch, which is the first panel of disconnect. It's the first place where there's a disconnect in the system. That's where the neutral and the ground need to be bonded. Now I'm going to make a separate video about that, and I'm going to go over the 2023 code. So be on the lookout for that if you need more information. Now in the safety switch, Luis will run the black cable to the first lug on your left, and then the red cable to the lug in the middle, and then the blue cable to the lug on your right. And then at the meter socket, the neutral cable went to the neutral lug, the black cable went right here, the red cable went right here, and then Ideal ran out of cable. So everyone was short one run. In this case, Luis couldn't make his blue cable run going to the meter socket. Luis has hit the timer, and that's it. It's over. That was an hour and 45-minute contest. Now the judges come around and check out all the contestants' work, and they grade them, and they make a decision as to what 5 contestants won. You see, 5 contestants out of the 10 will be moving on to the finals.
Welcome our top 10 semifinalists. Who's going to make it through to the next round? Only 5 will advance. You guys worked so hard on this first challenge, almost a 2-hour competition. You were all drenched in sweat, a lot of stress, but a lot of smiles as well. 5 of you rose to the top after a rigorous judging procedure, and I have those results in my hand. When I call your name, if you will join me center stage, you will be advancing to the finals. First to advance, Devin Slifer. Jake Tribby. Dino Gulandri. Feels great, doesn't it? Oh, it's great. You didn't know if you were going to make it or not, huh? Jose Renteria. Let's give a lot of excitement to Emma Becker. Let's give it up for our top 5. Also, let's keep it going for our other 5 semifinalists. Great work, guys. Nice job. Thanks so much. Also, a big thank you to all of our pros that assisted on that round. Huge help, right? Thank you guys for coming out here to help these guys and girls.
Well, our guy Luis Sanchez made it to the winner's stand last year, but unfortunately not this year. Better luck next time. I'll put links in my video description for all the great ideal tools seen in the video, and I'll also put links for the wonderful Siemens products that you saw in the video. Thanks for watching.
Mr.